What's up, guys? So I would do the intro, but today I just want to quickly get through this video because I've filmed this many times and there have been problems because I messed up creating the slides, so then it makes no sense. I've recorded this video about 6 times, so I've basically just been repeating myself like 1,000 times, and none of them are good. So this hopefully will be the last video I film for this episode that I'm trying to get out to you guys. So if you see this, yay, I did it. So let's just talk science. Here we go. So let's learn about these steps of the scientific method. There are 7 steps that you need to know. First off, you need to come up with a question that needs to be answered. So when you have a problem, put something about that problem, about a question that can be answered. And then you research about that topic. What is it that you want to find out about it? About that specific question. How will it help you in life? And then you form a hypothesis. You predict what you think the outcome to the problem will be. Uh, your hypothesis does not have to be correct. It's okay if it is not correct. Next up, you then create the experiment where you develop a procedure to test that hypothesis. And while you're doing that, you're going to create bar graphs and observe so you can make uh, correct conclusions, which leads me to the next one. You have to record the results of the experiment, also known as to collecting your data. Then when you collect your data, like I said, you put it into a graph, bar graph, or whatever it is, and you analyze your data, examine it, see what was the best about the experiment that happened, what was the worst thing that happened, what do you think you could have improved, what did you do really well. You have to figure that all out. And then you write a conclusion where you compare the hypothesis to the experiment results. And that's all the steps of the scientific method is. 7 quick, easy steps. They take a while, but those are the simple 7 steps. Now let's move on to energy. So, energy is the power derived from the utilization of physical or chemical resources, especially to provide light and heat or to work any machine. And there are 11 energy sources. And those energy sources are chemical, nuclear, thermal, electrical, gravitational, potential, sound, mechanical, kinetic, radiant, elastic, and potential energy. So now we're just going to go through all 11. Number 1 and 2, chemical and nuclear energy. Chemical energy is energy stored in the bonds of chemical compounds like atoms and molecules. This energy is released when a chemical reaction takes place and occurs. Usually, once chemical energy has been released from a substance, that substance is transformed into a completely new substance. Next up, nuclear energy. Nuclear energy is the energy that holds together the nucleus of atoms. Atoms are the most simple blocks that make up matter. Every atom has in its center a very small nucleus. In case you didn't know that. Normally, nuclear energy is hidden inside the atoms, and fission is also used used in nuclear power plants to make electricity. Next up, we have thermal and electrical energy. Let's start off with thermal energy, which refers to several distinct physical concepts, such as the internal energy of the system, heat or sensible heat, which are defined as types of energy transfers. And if you look, thermal energy, in the picture, you see a better definition, which is a lot shorter. It's just the energy of the moving particles in an object. Next up, electrical energy. That is the energy derived from electric potential energy or kinetic energy. When used loosely, electrical energy refers to energy that has been converted from electric potential energy. So there you go. So we now know chemical, nuclear, thermal, electrical, and now let's move on to gravitational, potential, and sound energy. Gravitational energy is the potential energy a physical object with mass has in relation to another massive object due to gravity. It is potential energy associated with the gravitational field. Gravitational energy is dependent on the masses of two bodies, their distance apart, and the gravitational constant. So there you go. And if you look at this picture, the green sphere has more gravitational potential energy because it weighs more if you compare the yellow to the green. Next up, sound energy. In physics, sound energy is a form of energy that can be heard by us human beings. Sound is a mechanical wave and, as such, consists physically in elastic compression and in displacement of a fluid. Therefore, the medium acts as storage for both potential and kinetic energy. Now we have mechanical and kinetic energy. Let's start off with mechanical energy. In physical sciences, mechanical energy is the sum of potential energy and kinetic energy. It's the microscopic energy associated with the system. The principle of conservation of mechanical energy states that in an isolated system that is only subject to conservate forces, the mechanical energy is constant. And if you look at the picture, the guy has a hammer and a brick with a nail in it. He lifts up the hammer, getting ready to swing it. And then in the third picture, he swings it down and the nail goes into the brick. So there you go, that's mechanical energy. Any sort of movement. Now, kinetic energy. The kinetic energy of an object is the energy that is possessed due to its motion. That's the motion energy. It's the ability to move. That's what kinetic energy is. It's defined as the work needed to accelerate a body of a given mass from the rest of its stated velocity. Having gained this energy during its acceleration, the body maintains this kinetic energy unless its speed changes. So there you go. Now moving on to radiant and elastic energy. Radiant energy is the energy of electromagnetic waves. The term is most commonly used in the fields of radiometry, solar energy, heating and lighting, but it's also used less frequently in other fields such as telecommunications. And if you look at the example of light, in parentheses, radiant energy, you have the electromagnetic spectrum that includes radio wave, microwaves, infrared radiation, visible light, UV light rays, X-rays, and gamma rays. Then you have as number 10, elastic energy, which is the mechanical potential energy stored in the configuration of a material or physical system as it is subjected to elastic deformation by work performed upon it. Elastic energy occurs when objects are impermanently compressed, stretched, or generally deformed in any manner. And if you see an example is a slingshot, something in the slingshot, where you pull it back, you put the thing in, and then you launch it, and it goes boom. Actually, it doesn't go boom, but just go with it. And then finally, we have potential energy. So in physics, potential energy is the energy held by an object because of its position relative to other objects, stresses within itself, its electrical charge, or any other factor. If you look at the picture, you have a blown up balloon. That is potential energy that's stored in it. And then when you pop it or let the air out or you untie the knot at the bottom, the air, as you see here, let me put it in present mode. Here, let me show you. So I'll grab my pointer. So you have the potential energy, and then when you pop it or you open this area, which I think is what it's supposed to do here by that, like the squiggle, I think it means that it's popping out and it's untied. The air comes out and it's moving. All this air and oxygen and helium is coming out to create kinetic energy to move. But it starts off as potential because you don't touch it and it doesn't move. It stays the same, doesn't move. And so there you go. I hope you learned a lot. We learned about the steps of the scientific method, and we learned the 11 energy sources. I hope you did enjoy. If you did, make sure to give this video a big thumbs up. Like this video. Go comment which energy source you like the most. Share this with any of your friends that you think might like this. Yeah, and then of course just subscribe to this YouTube channel because I make videos every day. Actually, nope. There's one day I don't make a video. So 6 days a week though I make a video. So please go like, comment, share, and subscribe. And I will see you all in the next video. Bye. Peace.